Well, good morning, everybody. Hold on one sec. Gracie, come here. This is my big pup. This is Grace. Good dog. All right. So we're back over to our stats problem. This is number 13. This is one of the versions. So I've had a good number of you request this one. So I'm just making this video to show you how it gets done. So we select a random sample of 83 StatCrunch U students, 50 females and 33 males, and analyzed their response to the question, what is the total amount in dollars of credit card debt you have accrued to date? With more than 30 in each random and independent sample, conditions are met for modeling. So what we're gonna do is we're gonna go through the formula approach, okay? And why do we have the T-model? Well, because we have sample standard deviations in here, okay? So this is our information for the females. This is the information for our males. And if you'll notice, we are doing the 99% confidence interval, and then we are estimating it using the difference mu1 minus mu2, where mu1 is the credit card debt for females, and mu2 is the credit card debt for males. All right, so I'm gonna pull away from that screen and I'm gonna show you the work that I did. So first of all, I took the information and I just put down that I have, for the sample size of females, 50, for males, 33. I have the X bar for females, 2587, the X bar for males, 2560, and the standard deviation is 1586 for females, and the standard deviation for males is 1523. My degrees of freedom are N1 plus N2 minus 2, or 50 plus 33 minus 2, leaving me with 81 degrees of freedom. Now, I'm going to travel over to here for just a second. So our formula for the confidence interval is going to be X bar plus or minus the T multiplier times the standard error. Now let's see how we got this. We are dealing with a 99% confidence interval. So what we're going to do is we're going to put 0.99 in the middle. That means that the two tails will share 0.01. So this tail and this tail are each getting half of 0.01. which means they get 0.005 and this side gets 0.005. Now, what I'm going to do is I'm going to take my graphing calculator and I'm going to do INVT, so second vars INVT, 0.005, comma 81, and I'll get negative 2.6379. Pausing for a moment, sorry. My throat is, it's a little raspy. Now, I could get that value as well if I go to the randomize on Jamovi, okay? So I'm going to do randomize on Jamovi, and I'm going to go to model based, and on the model based, to go to the right spot here. So we're going to use a T distribution. Our degrees of freedom are 81. And we are going to calculate the multiplier, but we are dealing with the 99% confidence interval. And we scroll over here and we're going to see our 2.63, and they rounded up to 8. And the reason that I showed the calculator is because this problem, this specific problem, seems to be really finicky with the number of decimal places that we have. All right, so I'm going to close this off and I'm going to come back over here. All right, so I have 4 decimal places here. I'm going to try and work out as far as I possibly can in this, and then I will come back and show you how far they take the decimal place out. All right, so we have our difference in means coming from the fact that we're taking the mean from the females minus the mean from the males, and we get a 27 as the value. Now notice it is positive, oops, forgive me. So we have 27 plus or minus the 2.6379. There's our multiplier. Now we got to compute the standard error, and that's no small feat. So remember that it's the sample size minus 1 times the standard deviation squared. Another name for this is the variance, plus the sample size minus 1, and again, the variance. So the standard deviation squared gets us our variance, divided by our degrees of freedom. And then we have this multiplier that actually ends up getting us to the standard error. If you can recall, this is the standard deviation of the pooled information. And this part here makes this value the standard error because we're taking the square root of things that have the sample size involved. All right. So we have 350.199. Now I'm going to travel over here and we're going to show you that we've got our x bar minus 2.6379 times the 350.199. Sorry for the typo. And we get negative 896.79. And then we have 27 plus 2.6379 times 350.199, which gets us 950.79. Now, I am going to go to another one of these problems, and I'm just going to, hold on, I got to back out for just 1 second. So I'm going to go to, give me 2 seconds here. There we go. Almost. Just give me a little bit longer. All right, I need to go to the teacher preview. And I'm going to the teacher preview. There we go. Now, this is not the same set of numbers. So note, this answer is not the correct answer based on the problem that I just showed you. But notice they're going out this many decimal spots. Even though they say 2, take it out farther when you put in your answer. And so when you do that, make sure that you've got a couple of extra decimal spots in there, if at all possible. All right, I hope that helps. See you guys.